With the COVID situation, everybody's working from home and using laptops to do meetings. You probably have noticed that the microphone quality of those laptops are pretty poor, which means whenever you have noise, the noise comes through along with your speech. So your speech is corrupted by this noise and it's hard for the other person to understand you. So we wanted to show that the SoundScript sensor, thanks to its directionality, is capable of removing the noise so that you only capture the speech. So what we did in the video you're about to see is that we set up a laptop with some SoundScript microphone, and we've added a loudspeaker away from the laptop so that we could blast some music and make the room as noisy as we could, so that we could then compare how does the different system on the laptop, whether it's the native microphones or the SoundScript microphones, behave in those conditions. We are about to listen to 4 different systems. The first system is an omnidirectional microphone with a SNR of 65 dB as it's connected to the SoundScript demo board. The second system is a single SoundScript sensor along the X direction with a SNR of 60 dB. We will be listening to the raw output without any software. This microphone is connected also to the demo board. The third system that we will be listening to is the full SoundScript microphone made of an X sensor and a Y sensor. Both those sensors have a SNR of 60 dB. Those sensors are going to be processed by SoundScript software algorithms to enhance the sound. And the last systems that we're going to be listening to is the native internal 2-microphone laptop array that is found in the laptop. This array is made of 2 omnidirectional microphones. That's it for the presentation and the introduction to the demo. I am now going to close this presentation and launch the video. I hope you guys will enjoy it. All right, so this is a typical laptop. And this is the one that I've equipped with a SoundScript microphone. So if we look at the top here, we have the evaluation board that we've designed for our customers. And these evaluation boards connect through a USB cable right here, so we can connect through Google Meet. So this laptop is also connected to this meeting right now, and we just don't hear the sound yet. And I'm going to switch to that sound later on. And on that evaluation board, we have some flexibility with microphone placing here. So for this very demo, I have first put an omnidirectional MEMS microphone over there, so then we can listen to the raw sound coming from a single sensor. And then I've put a SoundScript microphone right here. So let me just break down the SoundScript microphone for a second for you. So we got an X-axis microphone pointed like this, so that you can zoom on my voice and capture my speech with super high sensitivity. And orthogonal to that, we got a Y microphone, a Y sensor, that is also directional, and that I use to do software on increase the directionality of the system. So this combination of the X SoundScript sensor and the Y SoundScript sensors let us do super high quality speech enhancement and noise rejection. Right now, it's on 2 separate PCBs, but that's more like for R&D facilitation purpose. The end product, all those X, Y sensors are going to be collocated into one single PCB, one single microphone with a single lid. Just right now it's separated, but eventually everything's going to be just as big as this microphone over there. And in terms of functionality, at this point, it does exactly the same. Just to summarize, an omnidirectional microphone here, the SoundScript microphone right here, plugged in through USB right here, so we can listen to them and switch. So the speaker here is in order to add noise to this quiet room right now. And like fill it with noise to make it a bit more realistic, so we can see how the system behave in the presence of noise and speech. And the last system that I have for us to listen to is the thing that inherits native systems in the laptop. So behind this plastic here, so there is a hole here, and there is a hole over here, and behind those are MEMS microphone, MEMS omnidirectional microphone that we use to capture speech, that the laptop uses and process to enhance the speech and reject the noise. And it's not doing a good job at it. And I just wanted for us to listen to compare what we can do with the SoundScript microphone. So I'm about to blast some noise, and I'm about to switch to the laptop so that we can listen through that laptop. This is actually the sound from the single omnidirectional MEMS microphone that's hooked to the evaluation board. And as you can probably tell, it sounds good, you can understand me, so no problem here. But what happens as soon as I add some noise in that room? So let me add some music and you'll see how bad it gets. So I just added some music on top of my speech. Now it's probably super hard to understand. So let me turn off the noise. Okay, so the single omnidirectional MEMS microphone is mixing all sound together. And therefore, as soon as there is noise, you cannot hear me anymore. So now let me add in some noise, and then I'm going to switch to the sound coming from the SoundScript microphone, and you'll see how good we are at removing all that noise. And keep in mind that the noise is still going and the room is still noisy. So if you can hear me well, that just means, well, we've done a good job at removing the noise. All right, so let's do this. All right, omnidirectional microphone is noisy. And now let me switch to the SoundScript microphone. And this is the sound coming from the SoundScript microphone. As you can see, the noise has been completely removed, but it's still here. I can barely hear myself actually right now. So let's go back to the omnidirectional microphones for a second. All right, back to the omnidirectional microphone. Probably super easy again, right? So now let's just do a little bit more. I just want to break down the system and have you listen to the raw sound coming from the SoundScript sensor first. So I'm going to add in some noise again, and we're going to switch from the omnidirectional microphone to a single X-axis SoundScript sensor pointed towards my mouth without any software. And then we're going to jump to the SoundScript microphone with the software to see how we improve and how much noise we reject along the way. And again, the noise is going to remain constant across the whole section. So let's do this. All right, this is noisy with the omnidirectional microphone. You cannot hear well. And now let's switch to the SoundScript sensor, the single SoundScript sensor. Here, this is the raw output of our SoundScript sensor. It already rejects a lot of noise, but not entirely. And now what we can do is further remove that noise by adding the Y section, turning into the XY microphone. So this is a single axis, and we're switching to the XY microphone in 1, 2, 3, go. And now this is through the XY microphone. So we add another layer of rejection. And now just to finish, let's switch to the sound natively coming from the laptop, so the laptop array. I'm going to switch to the laptop array in 1, 2, 3. Here we go. This is the sound coming from the array. So the array, as you can probably tell, doesn't deal with that noise as well as we can do because they're using omnidirectional microphone. So let me go back to the SoundScript array for a second. Here we go. Back to the SoundScript microphone. Sound is clean, noise is removed, and it's much easier to understand. So now let me just cut the noise for a second. Directional microphone at the hardware level already reject a lot of the noise. And then by a proper combination using that XY architecture that we fit into a single microphone and a single package, we are capable of removing even further noise to really outperform any existing solution that you could build with omnidirectional microphone. So yeah, that was kind of the demo I wanted to show you today.